Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Mo's Algebra 2 class. Today we're talking about multiplying polynomials. Now, we've already defined polynomials, okay? A polynomial is literally an expression made out of terms. I have one term, or one-term polynomial is called a monomial, two-term binomial, three-term trinomial, etc., etc. We know how to find the degree of those, and we know that it is not a polynomial if the variable's in the denominator, if the variable has an exponent that is not a positive whole number, okay, or if it's inside of a radical, then it's not a polynomial. Multiplying polynomials are pretty simple if we remember our exponent laws. What do we do when we multiply the same base, guys? What do we do? What's the procedure? Yes, sir. That's right. You keep the base and you add the exponents. Great job. If you know that, life is going to be a lot easier. So when we're multiplying a monomial, one term, times a polynomial, simply remember the distributive property. And if you remember, the distributive property states that when I have A times parentheses A plus B plus C, that is going to equal AB plus BC. Why? Because I am distributing. Think of if I tell you to distribute this paper to everyone in the class. You've got to give it to every single person. It doesn't matter if there's an addition or a subtraction here. You're multiplying the outside value or variable, the outside term, to everything inside of the parentheses. Yes, sir. There is a little typo here. Yes, this should be an A. Thank you. I'll fix that right now. Thanks, kid. Thank you very much. Yeah, very, very good job. Way to go. Okay. Thank you, sir. So if you remember the distributive property, multiplying a monomial times a polynomial is literally the same exact thing. For example, simplify each. Okay. In other words, I'm asking you to find the product. So I have negative 2x squared times this 4-term polynomial inside of the parentheses. So I'm going to distribute. So what's negative 2x squared times 5x to the third? That's right, negative 10x to the fifth, because I keep the same base and add the exponents. Then I got, there you go, plus 8x to the fourth. Then I've got negative 6x cubed, because there's an invisible x there. No worries. Thank you, sir. And then I am left with plus 8x squared. Done. Done. Now, just so you can understand what's coming up. Next chapter, we're going to learn how to go from here to here. And if you notice, there's something that I can take out of every one of these terms. And I can take out a negative 2, and I can also take out an x squared from every one of those terms. That's coming later, but this is why we learn how to multiply first. Because when we're going backwards, you can kind of say, oh, okay, it's just the reverse of multiplying. So that's multiplying monomials times polynomials. So what would I get here, guys? Yep, 6y cubed plus, that's right, plus 15y squared minus 9y. Done. Have a good day. It's that easy. It's that easy. You're literally multiplying the outside term to every single term inside of the parentheses. How about for C? What would my answer be here, gentlemen? Whoa, sorry about that. But yes, you guys started right. So this is a negative 10x to the 9th. Excellent job. Plus 15x to the 8th. Excellent. Minus 5x to the 7th. Plus 20. X to the 5th and y. Remember, only x is being raised to the 5th power. You cannot add those exponents because they're not the same base, my brother. If you had written it like this, xy to the 5th, that would be assuming that the 5 is affecting the y. Had you written it xy to the 5th, that would be implying that the power of 5 goes both to the x and the y. Neither of those are good, because in this case it's 5x to the fifth times negative 4y. The x and the y are not same basis, so you cannot add the exponents. Does that make sense, son? Thank you, my brother. Not bad, right, guys? Pretty simple. Okay, let's continue. Now, multiplying polynomials. Okay, when we're multiplying polynomials, okay, I want you to try to remember FOIL. Stands for first, outer, inner, last. That's a really pretty name. FOIL. First, outer, inner, last. That's really cool. How does it work? Well, very simply. When I want you to find the product of two polynomials, that means that it's not a monomial and a binomial, or a monomial and a trinomial. It's two polynomials. So you're going to have maybe a binomial times a binomial, or a binomial times a trinomial, or a trinomial times a trinomial. Whenever you have more than one term being multiplied to another polynomial of more than one term, you have to use FOIL. And it works like this. First, outer. Okay, the first term, I'm going to multiply it out to everything in the other polynomial. So it's going to be x times x, which is x squared, x times 8, which is 8x. Now, inner, last. Now I take my inner value, the negative 5, and I multiply that to every single term of the other polynomial, or binomial in this case. So that will be negative 5x minus 40. Now I'm going to combine like terms. So I have an x squared. 8x minus 5x is positive 3x's because they have the same variable raised to the same power. And then minus 40. And that is the product of x minus 5 times x plus 8. And that's FOIL. You take the first term of the first polynomial and multiply it to every single term in the other polynomial. Then you take the second term of the first polynomial and you multiply that to every single term of the second polynomial. For example, 6x minus 5y times 4x plus 3y. I'm going to take 6x times 4x, which is 24x squared, plus 18xy minus 20xy minus 15y squared. Excellent. Now I have a like terms here. I have some like terms, 18xy and negative 20xy. So I've got 24x squared minus xy minus 15y squared. Two. I was testing you to make sure that you saw it. No, thank you guys. Minus 2xy. Because 18xy minus 20xy, you got negative 2xy's left over. Thank you, gentlemen. It's not too bad, right? Just got to be careful. You know, got to follow directions. Be careful. Unlike I was in this last example. Be more careful than me. How about for C? I got 4x squared times negative 2x, which gives me negative 8x cubed. Yeah, because remember that there's an invisible exponent of a 1 there, my man. Thank you. Then I got 4x squared times 5y, which would be plus 20x squared y. Then I got 3y squared times the negative 2x, which gives me negative 6y squared x. And then I've got 3y squared times 5y, which is 15y cubed. Do I have any like terms? No. No, I don't. Because I got a 20x squared y and then I have a 20y squared x. Those are not like terms. They are the same variables, but they're not all raised to the same power. So literally, that's my answer. Yes, sir. Yes, sir. No, the question was, could I rewrite negative 6y squared x as negative 6xy squared? No, not at all. That works because of the commutative property of multiplication, which states I can change the order of multiplication, but it doesn't change the answer. Thank you, sir. How about, we're good? How about this guy? 2x times 3x is going to be 6x squared. 2x times 5 is going to be 10x. Negative 1 times 3x is negative 3x, and negative 1 times 5 is. So now add up like terms. So I got 6x squared plus 7x minus 5. Does that make sense, guys? Yes, sir? Because 2x times 5 is 10x. Thank you, my man. No worries. Thank you for clarifying. That's what we do here. May I continue, brothers? Okay. Let's do this. Now, multiplying any polynomial times another polynomial is just as easy. Okay? It is very similar to the FOIL in the sense that each term of the first polynomial must be multiplied to every single term of the second polynomial. These are going to be longer answers, but still extremely doable. So if I have here x plus 3 times x squared plus 2x minus 5, I want this product. I want you to simplify this. We're going to literally kind of FOIL. The first term is going to be multiplied to every single term of the other polynomial. So this will leave me with x cubed plus 2x squared minus 5x. Now I take the positive 3 and I multiply that to every single term, giving me plus 3x squared plus 6x minus 15. So now I add like terms. So I have x cubed. I get rid of it so I don't double it up. Then I have a 2x squared and a 3x squared, so that's plus 5x squared. Got rid of those as well. Now I've got a negative 5x plus a positive 6x, so that's plus x. And then I got minus 15. So it's a little bit of a longer process. Just be careful when you're adding like terms. Be careful when you're multiplying. Keep those properties of the exponents together. Now this one's going to be pretty long, but it's still not too difficult. So I'm first going to take 2x squared, and I'm going to multiply it to every single term here. So I've got 2x cubed minus 2x to the fourth. My bad. Minus 8x cubed plus 6x squared. Then I'm going to take the negative 3 and distribute it to every single term, giving me negative 3x cubed plus 12x squared minus 9x. And then I'm going to take the 4 and multiply it to every single term. So I get minus 4x squared minus 16x plus 12. And now I add up like terms. So I have 2x to the fourth. There's no other fourth power. I'm done. 8x, negative 8x cubed minus 3x cubed. Thank you, my brother. That's negative 11x cubed. Beautiful. I got a positive 6x squared and a 12x squared and a negative 4x squared. So what would that be? Come again? Oh, it is a positive 4x. So I got 6x squared plus 4x squared plus 12x squared. So what do we get there? 22x squared. So goodbye, goodbye, goodbye. And then I've got negative 9x and a negative 16x. So it's negative 25x. And then I'm left with a 12. And that's the way we go. That makes sense. It's not too bad, right? All right. Now, how about C? What do we do with C? Same exact thing. I'm going to multiply 5x to every single term of the other polynomial. I don't care how many terms there are. So I've got 10x, good. Then plus 15x cubed, yes. Minus 20x squared plus 5x, right? And then I have the negative 4, which must get distributed to every single term. So I've got minus 8x cubed, yeah. Minus 12x squared, beautiful. Plus 16x minus 4. Now add like terms. 10x to the fourth, I don't have any x to the fourth, so that's it. 15x cubed and negative 8x cubed gives me 7x cubed. Beautiful, gentlemen, beautiful. Then I got negative 20x squared and negative 12x squared, so that is negative 32x squared. I am very, very proud of you. 5x and 16x, 21x, and then I've got my minus 4. Now, for D, guys, this is the one that I really need you to pay attention for because there's a huge pitfall that a lot of people fall for here. If I had 3x to the third power, what would that be? Go ahead. 27x cubed, right? Because when I raise a power to a power, I'm distributing this exponent, correct? Okay, so that'd be 3 to the third, then x to the third. But do you not realize that that's a monomial? So this power works when there's one product inside. One product. It doesn't work when there's a sum or where there's a difference. It works when there's a product. So most people are going to look at this x plus 3 cubed and they're going to go, oh, it's x cubed plus 3 cubed. And that's wrong. Do not do that. That is wrong. What this is really telling you guys, think about what the power of exponents. This is really telling you this is x plus 3 times an x plus 3 times an x plus 3. Well, what do we do here in this case? Well, we're going to go ahead and multiply these two first, and then we'll multiply the product times x plus 3. So x plus 3 times x plus 3, we got x times x, which is x squared, plus 3x, plus 3x, plus 9, which gives me x squared plus 6x plus 9, now times x plus 3. So now I have x squared times x, which is x cubed, x squared times 3, which is 3x squared. 3x squared. Then I have 6x times x, which is plus 6x squared, plus 18x, plus 9x, plus 27. And that should be a 9x. So at the end of the day here, my answer is x cubed plus 9x squared, beautiful, plus 27x plus 27. Does that make sense to everybody? Please do not fall for the trap, okay? If I give you x minus 5 squared, no, it's not x squared minus 25. No, that is wrong. Please remember that. If I give you x minus 5 squared, it equals, oh, x minus 5 times another x minus 5, and then you FOIL it out from there. Does that make sense, boys? Thank you, guys. Okay. Let's continue then. All right, now, special cases. I know there's a lot here today, guys, and it's not super, super fun. I appreciate your enthusiasm. I appreciate you following with me, okay? We're almost done. When we're multiplying special case products, guys, there's good news and there's bad news. you don't have to necessarily memorize this yet, but I promise you that if you memorize the rhythm here, it's going to help you tremendously for next chapter. So when I have the square of a binomial, x plus y squared. Again, it's not x squared plus y squared. No, it's x plus y times x plus y. If I go ahead and do this out the long way, I'm going to have x times x is x squared plus xy plus xy plus y squared, which equals x squared plus 2xy plus y squared. That pattern right there is a formula. That is the pattern that you are going to get every single time that you square a binomial. It doesn't work if you square a trinomial. It doesn't work if you're cubing a binomial. But it works if you're squaring a binomial. How did I get this? Well, it's very simple. There's a formula here. So let's go through it. The formula is going to be x squared plus 2xy plus y squared. You know why I did that. Now, you don't want to do that the long way all the time. So whenever you see a binomial being squared, think of it like this. Take the first term and square it. So what's the first term of x plus y? X. Square it. If you have a plus here, it's plus all the way around. Plus all the way around, so you don't have to worry about that. I'll tell you what happens with a negative. But you take your first term squared plus twice the product of the second and first terms plus the second term squared. If you memorize this, your tests, your quizzes, and next chapter will be a breeze. If you fight me on this, you'll still get the answer probably, but going the long way, you're going to waste time and you may not do as well as you had anticipated. So if I give you x plus 5 squared, me at this point, I'm never going to go, okay, this is x plus 5 times x plus 5. Let me start foiling. There's nothing wrong if you do that, though. Nothing, except you're just wasting time. What I do is I say, okay, first term squared, x squared, plus 2 times the first term times the second term. 2 times x times 5 is 10x. Plus the second term, which is 5 squared, which is 25. If I give you x minus 8 squared, this is first term squared minus 2 times first times second, so that's 16x, plus second term squared, which is 64. Very simple. Okay? If it's minus, if you notice, I'm going to have a minus for my second term. So here I have x minus 6 squared. It's going to be my first term squared, but this time that's a minus, so minus 2 times the first times the second term, that's 12x, plus the second term 6 squared. It's that simple. Now, I know that at first you see this and you go, oh, wow, that's nice, Mr. Moore, and I appreciate your honesty, but we're going to do it the long way, dude. That's cool. You will see eventually. Once you do it the long way, it's going to snap. You're going to say, okay, I see what this guy's saying now. This is a lot easier. Yes, sir. I don't know what you're asking. I'm not sorry. Yeah. To the first term and the second term. So in this particular case, my first term here is x. My second term is 6. Don't worry about the positive or the negative. All the positive or negative tells you is what sign to use here. So I have my first term squared. So x squared. minus 2 times the first times the second term. So what's 2 times x times 6? It's 12x. Plus my second term squared. Sir. The second term will never be a negative. Because think about it. A negative times a negative would be a, and a positive times a positive would always be a. So since you're squaring that last term, it's going to be plus. Thank you, sir. Does that make sense, guys? Okay, almost done. So now, let's do these. I am not going to use the long way. That is not the skill that I'm teaching. I am going to use the proper formula. So this is x plus 1 squared. Oh, if you need to remind yourself, you could say, okay, this is x plus 1 times x plus 1. And if you don't remember what to do from there, do it the long way. There's nothing wrong with it. However, this is a lot better. First term is x, first term squared, plus 2 times the first term times the second term is 2x, plus the second term squared is 1, and you're done. That's simple. This could literally be a problem that you do in less than 5 seconds if you understand the formula. I got 2m minus 5 squared. So I'm going to take my first term, I'm going to square it. So that's 4m squared, brothers. I have a minus here, so minus 2 times the first term times the second term. So 2 times 2m is 4m times 5 is 20m. Plus the second term squared, 25. And bada bing, bada boom, you're done. Sir, my brother, thank you.
Can you explain how you got the 20 again?
Sure. How did you get the 20 is the question. Thank you. The middle term, my brother, is 2 times the first term times the second term. Okay? So what's 2 times 2m times 5? Remember, the sign here in the middle is not a term. That's what's separating the terms. Okay? So it may help you guys if you wanted to do this, if that confuse you. It may help at first for you to say, okay, first term is 2m. Second term is 5. So I've got my first term, 2m squared. You don't have to do it in your head. Minus 2 times the first term times the second term plus second term squared. Do it like that for a while until you get the rhythm of it. Once you get the rhythm of it, then you don't have to worry. But remember, guys, I've done 1,000 of these. I'm not showing off. I've done 1,000 of them. Once you start practicing, you're going to be just as quick or even quicker than me. So then this is going to be 4m squared minus 2 times 2 times 5. That's going to be 20m plus 25. Thank you so much for your honesty. Does that make sense, brother? May I continue, gentlemen? Okay. What do I got here? N minus 4 squared. So I got first term squared, which is, yeah, minus 2 times first times second, 8n rather, excellent, plus second term squared, 16. That's the way you do that. That's the way you do that. For those of you that are looking at me like, what did he do? You could do it the long way. N times n is n squared. Minus 4n plus 16. Negative 4n minus 4n is negative 8n. You're going to get to the same place. This is just way quicker. Make sense? Okay. How about this guy? D, tell me. First term squared. 9x squared. Plus 2 times first times second. Yes. Great job, 48x. Plus second term squared. Bam. Have a good day. Does that make sense? And last but not least, guys, I know you're like, oh my God, another thing. Yeah, it's a long lesson. This is called the difference of squares, guys. This is the last one that we're going to do today. Well, this is the last type of polynomial multiplication. You just did it all today. You should be proud of yourselves. But when you multiply the sum of two terms times the difference of the exact same terms, the product will equal the square of the first minus the square of the second. This is called the difference of squares. And it's called the difference of squares because when you have a plus b times a minus b, you basically have the sum of the same terms times the difference of the same terms. That's what's happening. When this happens, guys, okay, you still don't have to technically memorize this yet. You could do it the long way. A times A is A squared. A times negative B is negative AB. B times A is plus BA. B times negative B is negative B squared. My negative AB plus the BA cancel, and I will always be left with the first term squared minus the second term squared, always, 100% of the time, no exceptions, if and only if you have the same two numbers being added times the same two numbers being subtracted. For example, x minus 5 times x plus 5. You could do it the long way, or you could say, wait a second, this is the first term squared minus the second term squared, so that's x squared minus 25. That's how I got that bad boy there. Does that make sense? It's not too bad, actually, is it? Okay. So again, how does this work? As follows. It's always going to equal a squared minus b squared. Why? Because it's the first term squared minus the second term squared. Always. Always. When it's a difference of squares. So, what would x minus 3 times x plus 3 equal? It's that easy. First term squared minus second term squared, you're done. I don't get it, Moro. Do it the long way. I promise you, you'll see it. What's x plus 6 times x minus 6? X squared minus 36, because I took the first term squared minus the second term squared. How about C? 4x plus 3y times 4x minus 3y. 16x squared minus 9y squared. Take the first term squared minus the second term squared. Beautiful. And last but not least, I got x squared minus 36y squared. Bada bing, bada boom. We're done. Does that make sense, guys? Thank you so much for your patience. I know it was a long lesson. Hope you learned a lot. Thanks again. Have a great day. Bye-bye.